Alright, here we go with our next video, day 2 of modeling of division of a fraction by a fraction. Today's learning target is students can use visual models to divide fractions with unlike denominators. So yesterday we worked on fractions with like denominators. Today we are working on fractions with unlike denominators. That is our goal by the end. Okay, we'll do some reviewing here also. Alright, if you're not done writing that down, go ahead and pause the video. I am going to move on to the next screen. In our first example, we are going to use a fraction bar method. Okay, so I have 12 fifths divided by 2 fifths. And you might be thinking, wait a second, Mr. Gaston, you just said we're going to have unlike denominators. Well, we're still dividing fractions by fractions, and our goal is to do unlike. But I want to review this because this problem here is 12 fifths. That is an improper fraction. So I want to show you that this still works, even if I give you an improper fraction. So we're going to make our tape diagrams, our fraction bars. So I have to make 12 fifths. How do you make 12 fifths? Well, that's going to require multiple fraction bars. Because one fraction bar, that's 5 fifths. So when I shade that in, 2, 3, 4, 5, that's not 12 yet. I got to keep going until I get to 12. 6, 7, 8, 9, 10. Got to make another one. 11, 12. Okay, so I have to make multiple fraction bars if I have an improper fraction. Okay, so that was step 1, is that I modeled my 12 fifths. That is 12 fifths modeled. Okay, now I'm going to divide by 2 fifths, which means I'm breaking it into 2 fifths sections. Since my tape diagrams are already in fifths, I don't have to worry about doing any conversion or anything. I just need to break them into parts of 2. So there's one part, and there's another part, and this one's going to go over. Okay, so I'm just working at it in sets of 2, and that's it. None left over. I'm done with my shaded. I'm always looking at my shaded. Now count them. 1, 2, 3, 4, 5, 6. So 12 fifths divided by 2 fifths equals 6. Okay, and that is my answer. And you can see here that 12 fifths is, if you're thinking about converting to a mixed number, is 2 and 2 fifths. So you can kind of see the conversion there too. That's the nice thing about making these models. Okay, so 12 fifths divided by 2 fifths is 6. If you need more time to write that down, go ahead and pause. Otherwise, I'll be moving on to example 2. In example 2, let's have a word problem here. Parker bought 11/8 cups of strawberries and eats 3/4 cup servings. How many servings did he purchase? Okay, so what we have here is we have to divide these. Okay, and how do I know how to divide them? Well, how much I have, my original amount there, that's the 11/8. So I'm doing 11/8, and then I'm breaking it into 3/4 cup servings. So I'm dividing that by 3/4. Okay, and we want to know how many servings he has. Okay, that's the key here. He bought 11/8 cups, but how many servings did he have? Okay, so I'm dividing that because this is my original amount of 11/8. That's how much I have, and I'm breaking it into 3/4 sections. You need to know how division works. Okay, now in this one, I cannot just make a straight up tape diagram because my denominators aren't the same. So when I make a tape diagram for 8, the 4 is not going to match that. So I need to make them have a common denominator. This is where LCM comes in handy. Look at the denominators and find the LCM. What's the first number they both go into? Multiples, thinking of multiples. Well, 4 goes into 8, so 8 is our LCM, which means I don't have to change this one, but I have to multiply this second fraction, numerator and denominator, both by 2, and that's going to give me 6/8. Now they have a like denominator. Now I can do what I did before. Okay, so first I'm going to do 11/8. Again, when I make my tape diagram, 4, 5, 6, 7, that's only going to be 8. Okay, so I need to make another tape diagram because it's more than 1. 1, 2, 3, 4, 5, 6, 7. And I'm at 8, 9, 10, 11. So you can see as a mixed number that would be 1 and 3/8. So drawing these models might help you convert between the two if you're struggling still. Okay, not that you have to do it, but it helps with the relationship. Okay, now I'm going to break it into sections of 6. 1, 2, 3, 4, 5, 6. So there's 1, and then I have 1, 2, 3, 4, 5, 6. So when I break this one up, I don't have a full section. That's a full one, but this one only has 1, 2, 3, 4, 5 shaded. So that's 5 of the 6 sections. So there is my final answer. Okay, 1 and 5, 6 servings. It's a word problem. Don't forget your label. It says how many servings. That is my label. So look at your problem to know what your label is. Okay? So he had 1 5/6 servings of strawberries. Okay? Again, first you need to find a common denominator, and then we can model. You need to do this for modeling. Okay? All right. And we're going to move on to our next example. All right. In example 3, okay, we're going to do an area model. All right. And so for this area model, guys, what we are going to do is we are going to first model the 2/3. Oh, wait, nope, sorry. First we have to find a common denominator because they're not the same. So the first thing we'll do is find a common denominator. So I look at the 3 and the 4, and that is 12. So they have a common denominator of 12, which means I have to multiply that fraction by 4 and this fraction by 3. That's going to give me 8/12 divided by 3/12. Okay? Now I'm going to model my first fraction, which is 8/12. So I got to model that. And in an area model, you can kind of model it however you want, as long as you have 12 sections. Okay, I could do 12 up and down sections, or what I'm going to do is I'm going to kind of 3, 4, 5. That's 6, and then I can divide it in half for my 8, okay, or for my 12, and then I'm going to shade in 8 of them. 3, 4, 5, 6, 7, 8. Okay, and then what I'm going to do next, okay, and I could have done that in a variety of ways. All right, I can make that look however I want. And then what I'm going to do next, guys, is I'm going to do the 3/12, and I'm going to basically group and see how many 3/12 I'm in here. That's what dividing by is. It's seeing how many groups you can create of that size. So I have one group of 3/12, second group of 3/12, and then when I look at my third group of 3/12, I only have 2 of them filled. So I have 1, 2, and then down here 2/3. Okay, and so your answer is 2 and 2/3, and that is your answer. Okay, now guys, in the area model you can make the 12. I could have made my area model for 12. I could have done, okay, there's 12 there, and shade in 8 of them. Okay, and then I could have done 3, and I can make my circles however I want. 3, a second 3, and then I have 2 left over of my other 3. So 1, 2, and 2/3. So your area model for this, guys, is you can make it however you want. So I have 12. I don't have to make it 12 long. I can make it any kind of combination I want, and then I'm circling the other number. Key is you must make like denominators. Okay, that is it for our video. If you need to pause or rewind anytime, go back and do that. Otherwise, have a great night.